Good afternoon. It's really wonderful to play these small, intimate rooms again, where I can actually see 20% of the faces instead of none of the faces. Hope you folks are having a good PDC. I've had a really good one so far. I took a long nap today, and I can only imagine the embarrassing digicam photos that were taken of me with various props while I was sleeping in the speaker lounge. What we're going to do today is take a look at what we're doing with Indigo. If you watched the circus act in the PDC keynote this morning that Chris Anderson and I did, we only got a chance to really dabble with any one given technology. We really wanted to try and give everybody a taste of what the whole platform felt like as a unit. What we're going to do now is forget all that stuff. We're going to focus exactly on what we're doing with Indigo. And Indigo is a very long-term commitment from Microsoft. Indigo began in 2000, and it's really exciting to be able to finally talk to people about it in public. And I hope everyone here gets a chance to play with the bits and spend some time with the technology. Let's go ahead and get started. No program is an island. No program is an island. Every program fundamentally needs some other program to do its work. As manly man or womanly woman as we may think of ourselves as programmers from time to time, and I don't need no stinking runtime, I don't need no stinking this, that, or the other thing. Inevitably, your program relies on something else in software to get its job done. And it turns out that it's not by accident that the first C program that many of us learned from the K&R C book, Hello World, the first, in fact, the sole executable statement in that program is a reliance, is a dependency on another program. That is the standard I/O library. You could write C programs without the standard I/O library, and in fact, the designers of C considered it to be a fantastic benefit that I/O was not a core capability of the programming language as it had been in other languages like BASIC and Pascal. Right? The fact that it was modularized into a separate library was seen to be a language feature. Yet, ironically, the very first C program that human beings encounter when they read K&R relies on that library. So programs need other programs to get their work done. It's impossible to think about a program that doesn't. And a lot of what I've done with my career in the last decade or so is look at how to get these programs to work together. That's what I like to do. Writing a single program to me isn't all that interesting. Getting a bunch of programs to do something together, yeah, that's kind of interesting. So that's what I do. And there's all kinds of technological ways we can think about getting two or more programs to work together. And it turns out that your program often depends on programs that are going to ship with your own. So in the 1970s and 1980s, well, the 1980s, we certainly thought about running our C programs with the standard I/O library built as part of our library, as a part of our application. That was, when I shipped my program, while I may have used code written by other people, the build environment of my platform would munge my code together with the code of these libraries that I was using. And we saw towards the end of the 1980s and certainly throughout the 1990s any number of technological approaches to decoupling, to breaking apart the physical packaging of your library and my application into distinct units. And certainly there was this dream that we would be able to independently version these things and independently deploy them. And we'll talk about what we know about that approach. Another really fascinating thing to see, if you look at all of these technologies for stitching programs together, is there's often been an attempt to say, well, gee, if my program has a dependency on this other program, which I'm probably going to want to run in my own address space for efficiency reasons, or maybe because there's no reason not to. I might also want my program to work with programs that run on different machines. And so throughout the late 80s, early 90s, and throughout all of the 90s, we saw a lot of different approaches that were similar but still distinct to taking one idea for bringing together programs and using that one idea both in the simple in-memory case as well as in the case where we're communicating across the network to another program. So, yes, it is the same problem. From the 50,000-foot view, it looks the same. And it has many of the same characteristics. But as we've seen through experience, and certainly anyone in this room who's tried to use the various technologies that every large vendor has tried to get out the door, knows it's not quite so simple. It's not quite as simplistic an equation as, well, all programs need to use the same technology in order to integrate, and of course that's the way we're going to do it. Certainly, we've had many, many challenges making it easy for developers to do this, right? And certainly my current employer, Microsoft, has had a plethora of technologies that made people in the training business quite happy, but people who actually had to ship software, not so happy. And I think you know which technologies those are. So, let's talk about what it looks like to have a world where we have connected applications, where we have programs that work with other programs. The approach that the entire industry was committed to in the last decade was this notion of objects. Objects, when the idea was first floated back in the late 70s and early 1980s, people thought, my goodness, this is radical. Today, no one looks at object technology and says, oh my God, that's a radical idea. Right? What a heretic, what a maverick. They want us to use OO on this project. Right? What kind of drugs are they on? Right? You never hear that kind of reasoning because by this point in time, 20 years hence, since the start of people using objects, we've had an entire industry focused on making object technology work. Object technology is fairly simple to use. Is it perfect? No, but it's fairly simple to use, and we know what the limitations are. And also, we've spent a lot of time working on reducing the performance tax. Right? If you think back to the early OO systems, the early OO languages and projects, right, there was a fairly high tax, especially if you came from a systems programming environment, such as C, where you were used to having fairly low-level access to the machinery. This whole notion of objects, and if you think about, say, the Smalltalk VM, the early implementations weren't necessarily things that would say, oh my God, that's what I'm going to write the next game on, even if that game was adventure, right, where performance isn't that sensitive. Objects in the 1980s were fairly nascent. And it took a long time for them to become viable to the point where now we don't imagine doing things any other way. It's interesting to note that it's only roughly now that we're starting to see operating systems that make deep commitments to object technology. Right? If you think about the 1990s, there were any number of projects that tried to go out with this notion of making objects an inherent part of the way we wrote software and integrated with the platform. Pink and Taligent being the most notable example of that. And it's only now that, say at Microsoft, we're finally willing to make the commitment to actually use object technology down in the platform. If you look at Windows XP, if you look at Windows 2003, they aren't necessarily built using object technology. The interactions between your code, your program, and our program, which is the platform, was not inherently object-based. The Win32 API was procedural, it was C-oriented, and it's only now with Longhorn, which still isn't going to ship for at least a few more weeks from what I could tell from that keynote this morning. We're still a few weeks or so away from having a production operating system, a mainstream operating system, whose primary access method is based on objects, right? The .NET framework's a wonderful thing, but let's be clear. Many parts of the .NET framework v1 are thin veneers on top of the old goop. And the old goop was not based on objects. It's only now, 20 years after the initial wave of object technology, actually 20N, where N is some number between 1 and 9, 20N years hence, that we actually have an operating system that is not only built using object technology, because believe it or not, we actually use C++ at Microsoft. There's a lot of the DLLs you use that rely on V-tables and V-pointers and things like that. But actually, the primary access mechanism of Avalon, of WinFS, of Indigo, those are managed code, common language runtime, this object-based system that requires you to adopt our way of doing objects. Right? The primary way you access Longhorn in the 3 primary pillars is to write managed code. That's object-oriented code. Today, if you're writing managed code, you are doing objects. Even in Visual Basic, if you write a module, if you ever look under the covers, you're doing objects. So it took us a long time to get to the point where not only were objects viable for every project you might be working on, but also they were viable for a giant, humongously large project like Windows to be built that way and exposed that way. So it took us a long time to get there. But I think we're about here. And I'm pretty confident we're not going to rip out the common language runtime. I'm pretty confident you're not going to be passing, window procs to Avalon and, cracking L-params. I have a feeling that's not coming back, right? I could be wrong, but I'm really, really believing that's not going to happen. Similarly, I believe in Indigo, we're not going to go back to sock ops and IN adder underbar any and all of those other nasty things that happen in the socket APIs. I think that era is behind us. Are there still people who stay behind and work at that level? Yes. It's okay. Ignore them. Every technological wave in which we raise the level of abstraction has stragglers. Back in the 90s, when Microsoft said, we're getting rid of this DOS thing and moving up the abstraction food chain to a world with, get ready for this, virtual memory, protected address spaces, preemptive scheduling, there were naysayers on the sidelines who said, not for me. My application is too important to move to this flaky new technology. I don't believe in this. I am going to stay with my physical memory addresses and interrupt handlers where I can really get control of the machine. Don't worry about these people. Ignore them. Natural selection takes its course. It is just a matter of time before those people become the minority, to the point where they actually just move on to other industries. Those of you who don't believe we're moving to this new managed platform and that everything is going to be managed, there's a phrase I suggest you learn in order to stay gainfully employed. That phrase is, would you like fries with that, sir? This is the direction we're headed. And in fact, we're there. It's done. Success. Grady Booch, Adele Goldberg, Bjarne Strustrup, all these folks who did this great work. We made it. Congratulations. And I'm really, really happy we got here in one piece. Now, there are good ideas and there are good ideas. Object technology is fantastic. I can't imagine not having object technology when I'm writing code. I would feel horrible if I had to work in a language that didn't have good support for object technology. I would feel terrible if I didn't have good platform support for this. And in fact, a lot of the 1980s was spent by people writing wrappers on top of this stuff, which added no value, but it just made them feel more comfortable. That's bad. It's good that we're in a world where this is the way things work. However, The way I want to, the way I want to think about the world, the set of abstractions at my disposal, when I am writing a single program, may not necessarily be the same ones I want to use when I think about forming a system. When I think about a system of cooperating programs, I'm not convinced that the same metaphor will work. Why am I skeptical? Because I lived through the object wars. I spent a lot of my time trying to make COM stretch. This wonderful metaphor, this notion of binary contracts and V-tables and V-pointers that can be transparently remoted, was an attractive elixir. It looks and smells awfully sweet. However, it turns out it's kind of hard to make work in reality. Looks good on paper. Fantastic idea on paper. Single programming model. It's the one I already know, which is good. So we take objects which we already were moving towards anyway, and let's just stretch it out and see how far we can take it. And what did we find? We found that it was exceedingly difficult to make work in a real production environment, especially when we take into account a lot of non-technical but super real issues. Like, what are the choices being made by the ecosystem around me? I work at a company. What are the technology choices being made? Are they being made consistently? Are they even being made sanely? Maybe not. But I still have to get this stuff to work. So the whole idea of using object technology to build systems of cooperating programs relied on a premise which was false. And that premise was all programs will share as much as humanly possible. We will share a type system. We will share perhaps a programming language, maybe not. Perhaps an object model, perhaps a deployment model. There was such a reliance on commonality, on shared infrastructure in the world of distributed objects, which was this notion of trying to use object technology and stretch it out to build systems, that we stretched it until it broke. How many people in the room, I will not do a lot of polling, but I feel once in a while it's fun to do a poll. How many people have had experiences using DCOM in this room? How many of those experiences were seamless? Okay. So obviously, we weren't there. And just to be fair, right, I want to make sure. How many people have had experiences using Corba? A few people. In fact, most of those people are still back there trying to get it to work, but sorry. Couldn't resist. An occasional cheap jab at the competition is allowed, I think. I think it's reasonable. How many people had seamless experiences with Corba? A few people, but again, not the vast majority. This notion that I can take a single metaphor that is designed for the local case, the in-memory case, and stretch it was an idea that everyone in the industry, myself included, I will plead guilty, thought, I'll bet we could make it work. But we were wrong. We weren't able to make it work. And the fact that virtually no systems are built exclusively using DCOM or Corba is evidence to the fact that we weren't able to pull this off in a broad, industry-wide way. Which is really what we need in order to get the network effect of having an industry making something to the point where we can bake it into the operating system and bake it into the programming languages. This distributed object technology, which many of us have used, has always been tacked onto the side, and we never had one of them. We always had N of them. And they always had these weird issues that made it very, very hard to deploy. And so what happened was we never achieved critical mass. The way we achieved was something as simple as, say, HTTP. No one doubts that HTTP is here. Right? No one is predicting HTTP is dead. HTTP will be here forever. And it actually works. Why does HTTP work? because we had an entire industry saying, we have to make this work. The people who actually pay our salaries care about this stuff. This isn't just some intellectual exercise. We need to make this work, and we need to make this work well. And so we have Apache, and we have IIS, and you can have your preferences, and those are both reasonable choices. But we know they work, and we know they work really, really well. This doesn't help us, though, in terms of building systems. Turns out that just saying, well, HTTP works, doesn't mean HTTP is the thing we should be using everywhere either. Because HTTP is, at the end of the day, a very, very fortunate hack that got groundswell and worked. But we don't necessarily want to use that as the metaphor for building everything either. So what are we going to do? Well, the experience of doing web services, the experience of using SOAP and building SOAP and watching SOAP spread around the industry has given a lot of people who work in this field an idea that maybe there's a different metaphor for integrating multiple programs that we can make work well in the distributed case, and we have proof points for that. Maybe, just maybe, we can take that new metaphor of a service and use that as a way to bring together programs of all stripe. Not only programs across platforms, but also programs on my local box. We'll talk about how this is going to work in a few minutes. The fundamental premise of this service-based world, this idea that we will use service orientation rather than object orientation as the way we model systems, relies on this idea of a boundary. Having a very, very strict boundary between programs is the way we think we can make services work. And we're not the only ones. This turns out to be, a kind of a growing idea. To demonstrate this idea, what I'd like to do is pick a volunteer from the front row. You raised your hand first. Would you mind coming up here, sir? There's some stairs right here. What's your name? David? Thank you for coming up. Have you and I discussed this demonstration prior to this moment?
No, we have not.
Have you and I ever met before?
I asked you a question yesterday.
You asked me a question yesterday, and did it have anything to do with this demonstration?
No.
And do you expect any cash to change hands after this talk?
It'd be nice, but I'm not counting on it.
Don't count on it. So, I'd like you to stand right here, if you would. So David is going to play the role of a program. Don't move. David's a program. And if I were in the object-oriented world, where boundaries aren't necessarily as important an idea, my integration with David would rely on many, many, many things happening. And I have a feeling that you're not very comfortable right now. Do you feel like the system is strong and we have a lot of integrity in this system?
Saying no.
Yeah. Do you think this system will last for another 20 years this way?
I'm doubtful about the next 10 seconds.
Yes. So you can see boundaries are important. They're important in real life. They're also important in software. There are many ways that boundaries exist. I showed you kind of the most obvious one, which is, I got all, physical with him and got really in his face. But there's any number of ways I could violate the boundaries that exist, in this case, between humans. For example, David, how much money did you make last year? You don't need to answer. It was for demonstration and pedagogical purposes only. So we've seen that boundaries are pretty important. David, you've done a wonderful job. Would you mind returning to your seat? Thank you. There's an important lesson there. There's two. Don't sit in the front row at a Don Box talk. And never volunteer. That's the worst. The second one is boundaries are a really important thing. And intuition you have about the real world is often fairly accurate about the software world. Right? The fact that boundaries are important, the fact that very few people on the planet would think to walk up to David at a PDC and crawl all over him and do all that stuff, tells you something. That there are sound social mores that keep us from doing that. If we all did that, my God, this talk would be a very fascinating one for me to watch. But you all might be very disturbed. So this notion that the real world says boundaries are important and that we should respect them. And for me to violate those boundaries is a very exceptional case. Now, are there times it's reasonable to crawl all over someone that way? Of course there are. You know what they are. I don't need to tell you what they are. Are there times when it's reasonable for me to ask someone, how much money did you make last year? Sure, if I'm an accountant and you're my customer, of course I'm going to ask you how much you made last year. It's important. Right? If I'm your spouse, I'm going to ask you how much you made last year and why don't I get more of it, right? Especially if I'm your ex-spouse. So it turns out there's any number of appropriate ways to cross boundaries, but they're exceptional. Our society relies on people respecting these boundaries so that we can all go about our daily business, living a full and rich and happy life, and occasionally interacting with others. And when we interact with others, well then, hey, what happens? Better stuff, right? When you get together with other people, you can often do things you could never do by yourself, right? I joined Microsoft mainly because I wanted to work with a lot more people than I could work with on my own. And so I found I was able to get more done. I was able to accomplish more, get more things I wanted to see happen because I was able to join up with a bunch of other people who, while we respect each other's boundaries, we have some agreements in place. In fact, there are actually contracts in place to make sure that we deliver on what we say we're going to deliver, and that by doing this, we're able to actually build something which is bigger than any one of us could have built. This is what service orientation is about. Taking this real-world observation about boundaries and applying it to the world of programs, making boundaries explicit in the world of software. So what is this service-oriented model that we're about to embark upon? It's really, really simple. We have services, we have clients, and we have systems. What is a service? You're going to, one of the interesting things is, if you watch the industry, the trade press, which loves to print stuff, because that's what they get paid to do, what you've seen is a lot of this SOA business, right? The world is starting to use this SOA acronym over and over and over again, service-oriented architecture. Well, what we're trying to do with Indigo is actually make service orientation, bring it down to the, to the people, to the masses, so we can actually build programs this way, right? We love highfalutin architecture diagrams like the next guy, but we're actually in the business of making programming languages work well and programming systems work well. So we think of this world as a bit more pervasive than just this high-level architecture, but rather as a set of concrete technologies. And in this general idea of service orientation, what is a service? It's really easy. A service is a program you communicate with using messages. Full stop. End. That's it. A service is a program that you communicate with using messages. No more, no less. What's a client? Simple. A client is just another program that uses a service. How does he use the service? He sends a message to it. It's that simple. Finally, what's a system? In the world of object orientation, we thought of applications. I'm an app developer. Where's the killer app? Right? That was the idea of object orientation. In the world of services, we think in terms of systems. This notion that you deploy something and you're done is a fiction. Yes, it worked in the 80s when we were building shrink-wrap desktop applications. Maybe it worked there. But certainly the real world, where we actually are writing programs that have to exist, coexist, with a lot of other programs and a lot of other situations in the real world business processes. I am building a system. I am building and maintaining a system. I'm going to start building the system piece by piece. But believe me, new pieces will come, old pieces may go, and this idea that I ever have a consistent deployment state is a fiction. If I get it, hey, great. But I can't rely on it. Why? Because that's not the way the world works. There is always stuff changing. Things change in my life. Things change in your life. Things in the real world change. Why would we think it would be any different for our software? It's not. And so service orientation says an application isn't really the interesting outcome of this process. Rather, having a system that's up and running and will change over time, that's the high order bit. That's what we're actually headed for. And this is what we're working on. So, how do I think about writing software in this service-oriented world? It's really simple. We have 4 simple rules, which when we start talking about Indigo, the technology, when I show you the DLLs and the IntelliSense and all the other obvious stuff, the thing you need to keep in mind is that these 4 tenets are what we are building a platform for. Yes, at the end of the day, Indigo is just another set of DLLs, just like COM was another set of DLLs, just like Avalon is another set of DLLs. The thing we're actually headed for, the thing we are trying to institutionalize in technology, is these 4 tenets. The first one is, I've already said, boundaries are explicit. I want to make sure as a programmer, as a developer, that I know where the lines in my programs are. This notion that I can simply take my code and through config, it all instantaneously becomes a web service is naive. In case it wasn't obvious, it was naive. Do platforms support it? Damn straight. Does ours? Yes. Should we have done it in in hindsight? No. But we did it. And we are going to atone for our sins with Indigo. Now, boundaries are explicit. We know what we're doing, and the whole premise is based on developers opting in. You must take an action in this service-oriented world in order to make parts of your code accessible. None of it comes automatically. Doesn't mean we make it hard, but we do make it explicit. Tenet number 2. Services are autonomous. I need to make sure that my program works, even if yours does not. What does this mean? One thing it means is that because I am going to be part of a system that has other programs that I have no control over, I have responsibilities. There's an expectation of reliability and availability. That when I put a service out into the world, that there's some notion that I will keep it around and that it will be available. That over time, if I need that service 6 months hence, that it will still be there. And it will be there in a predictable way. Moreover, I have to be 1,000 times more concerned with security. Because quite often, these services that I deploy are going to exist in a world where packets can fly freely. I can't always rely on having a firewall installed that will protect access to my service. So having excellent support for being able to do secure, authenticated communications and having a rich way to do authorization is a pretty important capability. And if I don't have that, and I want to live in this service-oriented world, what am I going to do? I'm going to roll it myself. And while it might be fun to roll GUI code yourself, like there were certainly any number of frameworks in the 1980s for doing user interfaces, it might be interesting to roll your own RPC framework or serialization framework. The one thing you don't want to roll yourself is security infrastructure. Security infrastructure needs to be solid. It needs to have as many eyes as humanly possible on it, so that we have some hope that it is, in fact, secure. So security and reliability are super important in this autonomous world. Another interesting facet of being autonomous is that we're going to deploy things independently. I'm going to deploy David, and then Steve over here is going to come up on the network. And I'm going to expect Steve and David to be able to work together. Now, they had some, there was some shared knowledge between the two of them in order to get them to work, and we'll talk about how we'll do that in a second. But I expect them to work. But now here's the issue. Steve's out there relying on David. I'm going to have to redeploy David because I found some other stuff I need to do to David. And I need to make sure that as David evolves, I have some way of controlling what happens to everyone else in the system who's relying on David. This notion, which we had when we thought about distributed objects, of a schema repository or an interface repository, this notion that we have a centralized place where we can put all information, doesn't exist in the real world. And so I can't rely on changes made over here to necessarily propagate out to Steve in order to ensure correct operation. And because I need to change you and I can't change him, that means I need to make technological choices that ensure that I can actually do that evolution in a way that's safe and sane and not completely Wild West. So this is a technological problem, which of course we're going to deal with. Tenet number 3. This one in some ways is a corollary to the previous tenet, and in other ways it's not. It's really important though. In this world of service orientation, we do not share classes. Instead, we share schema and contract. In the world of objects, we had this thing called a class. A class was a wonderful thing. A class simultaneously brought together state and behavior into a single atomic unit of abstraction. And in a world where I have all of my program at once being deployed and being executed, that's not such a bad thing. In fact, it's a wonderful thing. I'm not going to sugarcoat it. It's fantastic. It's like crack. I love it. Not that I love crack. But it has the same effect. It makes you feel extremely good. This is all from what I've seen on in the news. Yes. I have not done extensive research in this area. So, classes are fantastic when I can test and integrate them as a whole with my program. What we have found is that when we have this autonomous world where David and Steve and Jane and Ringo's evolution is all independent, it's very, very hard, if not impossible, to make that work, especially when we go back and start thinking about autonomy. Because to have a class that's shared between Steve and David, that's a very, very deep, deep commitment. Because for us to share a class, that means there has to be not only a wire representation or an in-memory representation of the class, there also has to be code associated with that class. Because the idea is Steve's going to create one of these things, and it's going to wind up over in David's program, and now all of a sudden we're letting Steve inject arbitrary code into my mission-critical service that is responsible for all the payroll and accounting for my enterprise. And I'm just going to let your code, and we'll use object orientation, so we'll use inheritance, right? So not only will I allow you to have a single class that we both share, but if you'd like to subtype that thing, party on. And I'll load that code too. We thought that way. If you ever looked at DCOM and you looked at iMarshal, iMarshal was based on this ability to poke an orifice into another program and reach in there and put some code that runs. Java RMI is based on that same orifice. And if you're comfortable with that degree of intimacy with another program, it is a reasonable technological choice. But we're moving away from that world. We're moving to a more responsible world where we don't want that degree of intimacy. So what we do is we state the following. We have either schema or contract. Schema describes completely structural things. It describes wire format or in-memory layout if we're actually doing same platform work. That's all a schema gives us. It allows us to string together composites of primitive values like integers and strings into simple data structures that are purely structural and have no behavior. Or we have contracts. What are contracts? Contracts are like schema over time. A contract describes a set of message exchanges between services in terms of purely behavioral interactions. And in fact, those interactions are messages which are themselves schematized. So in this world of service orientation, we do not have classes which conflate state and behavior. Instead, we have schema, which is all about representation, or contract, which is all about behavior. And never the twain shall meet. Very, very important. Great. Then finally, the fourth tenet. We saw boundaries are explicit, services are autonomous, we share schema, not class. The fourth and final tenet is that we do policy-based compatibility. Because we have schemas and contracts which may need to evolve, we can't assume a centralized common type definition. This was a very, very important thing for me to understand after working on XML schema. A lot of the original work on XML schema assumed that everyone on the planet would use a common XML schema against a particular piece of data. That is a naive viewpoint. I will have my schema with my validation rules over the data. That will be distinct, albeit maybe similar, but it's distinct from the schema that you're going to use on your side to validate that exact same data structure. My constraints may be tighter or looser than yours. My set of default assumptions may need to be different from yours. The way I map that to various technologies I'm using may be different from yours. So the idea that we're going to have a shared schema and that it's going to go in this centralized global schema repository is an absolute fiction. So what are we left with? I need to have some way of knowing, does the program I wrote today have a prayer of working with your program, which may have been deployed yesterday and will be redeployed tomorrow? The way we do that in this service-oriented world is based on this thing called policy. And what policy does is it associates stable global names based on URI with ideas, with concepts. And when I determine whether my program can work with your service or whether it cannot, the way I make that calculation is not simply by saying, do we have the exact same interface definition? That's not the way we do it. Rather, what we look at is, what are the capabilities of that service and what are my requirements? And we express those in terms of stable global names. And we can use that idea in any number of facets. We can use it in discovery. We can use it in directory services. We can use it anytime we need to determine, is this the service I need to use? So, we saw the four tenets. Enough of this highfalutin conceptual model goop. Let's start looking at some DLLs. So, the good thing about this talk is you can actually take these ideas back and use them today. The platform we've already shipped is workable. At the very least, workable. And in fact, pretty reasonable for building service-oriented programs. It's not obvious how to do it. We don't come out and tell you this is what you should do if you want to live in this service-oriented world. But people who've been using this technology in the field for the last 2 or 3 years have already come to these conclusions, which I'm about to tell you. The way you program service-oriented programs now is to use a technology sometimes called ASMX, sometimes called ASP.NET Web Services. Of the various technologies we have that support distributed communications, messaging, XML, web services, blah, 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 of all the technologies we've got, and believe me, we have our share, the one that is the closest to the truth is ASMX. Is ASMX perfect? No. Is it ideal for every possible situation you would ever have for sending a message? No. Is it good enough for most of the services you need to build today? Probably. So ASMX is definitely your best bet today if you want to build services. And quite honestly, the best way to understand service orientation and how it differs from object orientation is to spend time thinking about ASMX and .NET remoting. Nowhere have I seen in anybody's technology stack a clearer example of the two mindsets butting heads. .NET remoting, which many of you I'm sure have used, is a fantastic implementation of the object-oriented and distributed object-oriented paradigm. In fact, I would argue it is the finest implementation of distributed object computing ever to be released. It is excellent. People who get near it enjoy it. They find all the extensibility points they want are there and fairly accessible. It's infinitely pluggable. It's a fantastic technology for doing distributed object computing. If you were a Corba head or a Java RMI head or an EJB head coming to this platform, .NET remoting made you feel safe because it did everything you were used to. And we are committed to making .NET remoting work now and forever. It is never going away. However, it is not the future direction. It is not the way we think most people should be building these systems that consist of services. Can you do it? If you are extremely disciplined. Those of you who were writing OLEDB providers in assembly language, you're there. We got a technology for you. I'm confident you can safely and easily build service-oriented systems using .NET remoting. But quite honestly, it is such a seductive technology. The problem is the technology is too goddamn good. It's too compelling to want to use so many of those object-oriented features that don't translate into service orientation that I cannot, in good conscience, recommend that you go use .NET remoting to build these services. That is, to integrate these services. ASMX, on the other hand, is not the best technology on the planet. I don't know how to break this to you. .NET remoting, much deeper thought, much richer architecture, baked much closer into the CLR, fantastic. .NET, ASMX, no, it's not. ASMX is a reasonable implementation of a couple of really good ideas. It is interesting, the most profound aspect of ASMX, and we'll actually talk about a few of them in this talk, but the most profound one, the single differentiation point which really drives home service orientation versus object orientation is the way proxies work. In .NET remoting, we perform unnatural acts. Dogs and cats marrying unnatural acts. In order to make sure that when an object reference is marshaled outside of my native app domain, but then comes back around, I don't have a proxy. That was the way DCOM worked. Right, in DCOM, in COM in general, we had this rich marshalling architecture with contacts and apartments and all that other stuff. When object references came out and came back, we ensured object identity and we made sure that you got the real object and the proxy infrastructure got out of the way. That's what .NET remoting is about. It's about this notion that we will make objects work in a distributed fashion, but then we'll always come back to the local model. In contrast, ASMX doesn't do that. Now, you could say they didn't do it because they didn't think to do it. You could say they did it because they were, visionaries. I don't know, and I don't really care. All I know is the technology does the right thing. It forces me to think, wait a second, this is a proxy. This is going to be different. When I call a method on this thing, even though I'm going to use methods because it's a little more convenient, I'm leaving. I'm leaving my app domain. I'm leaving my process. I'm leaving everything. And even when that URL for my web service in ASMX goes out and comes back in, ASMX makes no attempt to do the short circuiting and get the proxy out of the way. Because this access mode of accessing my code like a service should be distinct from accessing my code like an object. And that turns out to be very, very profound. And when we talk about Indigo in detail today, and I hope some of you come to the Indigo sessions tomorrow where we're really just going to rip apart all the DLLs and see how they all work, you'll see that idea permeates the way we think about things in Indigo. So, ASMX is a great way to work today. It's there. You should really consider it. There's a lot of really innovative work there. But we're doing more. So, for the past 3+ years, we've been baking Indigo. And Indigo does a bunch of things. It's actually a very simple technology with just a couple of DLLs that make it all work. But actually fills many roles. It serves many purposes for you, the developer who's living on our platform, and to a degree for us, the folks who have to keep this platform going. Indigo is .NET technology for building and deploying service-oriented software. That's all Indigo is. It's just a bunch of technology that allows us to build services and deploy services into systems. It makes it simpler to build connected applications. And most importantly, we respect the environment around us. We don't necessarily assume that the entire world is going to have Indigo. We don't assume the entire world will have Longhorn. We don't assume the entire world will have Windows. Not only do we not assume the entire world of programs will, we don't assume all of your programs are going to move to Indigo overnight. We fully expect that if you're in this room, you've already written some code on our platform. And hey, thank you, bottom of my heart, it's great, thanks, we appreciate it. And we want you to keep writing code on our platform. And we expect Indigo to come into your life, and we don't want it to be overly disruptive. So we take seriously the environment around us, not only in terms of the other platforms that exist, because obviously, there will always be a dozen people on the planet who don't run Windows, right? It's just a known fact, right? They used to run OS/2, then they ran the Amiga, now they run Linux, and they'll move on to something after Linux. Those dozen people who post to Slashdot, they're never coming. The rest of the world, though, we know will run Windows. It's just a matter of which version, and that's another issue for us. So let's talk about what Indigo is. Indigo is a technology that causes PowerPoint to lose the R in connector. Indigo is fundamentally a bunch of DLLs. It's a bunch of DLLs that ships in the box with Longhorn. So if you have a Longhorn machine, you go to your mom's house, right? You want to write a program, you know Indigo will be there. Indigo does not require Longhorn. Again, we respect our environment. We're all about keeping these programs working together. So it would be odd if we said, we'll help all these programs work together if and only if you all upgrade to Longhorn, this operating system we're not going to ship for at least a couple more weeks. So instead, Indigo actually runs on Windows Server 2003, Longhorn, and Windows XP. So by the time we ship the predominant versions of Windows that are out there, we'll have implementations of Indigo on. And you can install us the same way you install any other version of the .NET framework, right? You install WidBee. We're just another framework in terms of WidBee's world. So getting us on the box is a fairly tractable experience. You don't have to go off and reinstall the operating system. We would love you to reinstall the operating system. Longhorn's obviously very sexy and flashy, and you saw Hillel's demo. I mean, I want that thing. I mean, I got all excited. But not everybody's going to move overnight. So Indigo runs on these other platforms as well. Let's talk about the DLLs that are part of Indigo. And my goodness, the video here is just like eating every last letter. Look at that. That's horrible. That's horrible. Whatever. So, the primary entry point into the Indigo system for most developers is the service model. If you recall from .NET Framework v1, we had system.component model, which at the end of the day was a WinForms feature that we used to hook up designers in Visual Studio. We're actually making very deep commitments to service-oriented programming on the Common Language Runtime. And we have a DLL that gives us explicit support for doing service-oriented programming. Some of that support comes in the form of doing instance management and context management. Some of it comes in the form of having declarative attributes for setting up boundaries, for controlling the contract of your code so that you know what parts of the code are going to be externally visible. It's also where we do all of the type integration. It is the boundary between the world of objects and the world of services. It is the thunking layer. It is the impedance matcher between objects and services that has deep, deep, deep ties to the common language runtime. We have a set of declarative behaviors that we ship out of the box, as well as an extensibility model for you to write these things. This is where we get the average developer involved with things like security, with things like reliability, and with things like transactions. And then finally, we have rich support for transactions in services. The way we know how to make things reliable. I mean, you know, Microsoft Research is a fantastic place, and I look forward to them coming down from on high with the stone tablets, telling me the one attribute I add to my code to make it completely reliable. Until that day happens, the way I know to make my code reliable, especially in a concurrent world, and in a world where we have partial failure because we have autonomous services, is with transactions. That doesn't necessarily mean we're going to have transactions spanning the world. Don't mistake this for we're going to marshal transaction references from here to Cambodia. That's not the case. But having transactional programming as a first-order concept throughout the way I write my code turns out to be key to the way I make my services reliable. And we get that support in system.service model. System.service model is really just a way of thinking about structuring code. In order to get the connectivity to the rest of the world, especially the rest of the world that isn't running Windows. And I joke about the dozen people. There's dozens of thousands, if not dozens of millions of people who aren't ever going to run Windows, and it's just okay. It's just okay, but it's okay. And the way we're going to get to those people is by using this thing we call the Indigo connector. And what the Indigo connector does is it allows me to take messages that are SOAP messages, that are aware of this service-oriented model, and move them from place to place in a secure and reliable fashion. And it's in the connector that I get basic connectivity. It's where I get all of my message and session-level security. It's also where I get all of my reliable messaging support, including durable messaging. So we have a single messaging stack which I can load anywhere. And quite honestly, I can use the connector without using the service model. In fact, those of you who came to the keynote this morning, when Chris and I were writing code with Indigo, we were just using the connector because it's the easiest thing to use on the PDC bits. That won't be the case by Beta 1. Another thing we do in Indigo is we don't know how you want to get your program started. Right? If you look at other technologies that Microsoft and other vendors have done, right, they either leave you on your own and say, we're like sockets, and you can do whatever you want, but you got to do it yourself. Or they're like an EJB container, or like Com+, and say, we know what's better, right? We obviously are the vendor, you're just the peon developer, you will run inside our environment, and if you don't like it, there's the door. Neither one of those approaches is acceptable by themselves. Some people want us to do it, some people don't. What we've done with Indigo is we've invested a lot in making sure we have excellent support for both self-hosting services as well as hosting within all of the common infrastructure that we have on the Windows platform. We are a technology that runs on Windows, and we need to be great Windows citizens. We've done a lot of work to integrate well with ASP.NET. So if you like the ASP.NET config model and deployment model, you can use Indigo there without having to worry about some catalog or registry or configuration database. If you like using the NT Service Control Manager, you can write an Indigo service as an NT service. We're fine with that. You want to run in DLL host.exe, which is the old school COM surrogate? Go for it. Go in peace. We're actually doing the work to make that possible and easy. Also, if you're an Avalon developer, which I know by the end of the week we'll have thousands of Avalon developers out there. If you're using a .container, which is the way we host Avalon applications instead of .exes, which you should go hear Chris Anderson talk about on Wednesday. We're also supporting .containers in the fullness of time, before we ship. It's not in the PDC bits. But by the time we're done with the release of the product, we'll also have support for integrating with Avalon hosting. So that vertical stack, which is, hold on, let me use an AV trick here. This is really the core of Indigo. This is the thing we expect every Indigo developer to get involved with, to use to some degree or another. Now, you may take a specific slice down that vertical stack, but we expect each of these three boxes to touch every developer that uses Indigo. In addition to this stack, we have a set of services that are exposed as, guess what? Services that allow you to do additional things that are very commonplace in applications. We have some system services. Specifically, we're adding support for federation of identities to Windows security that will be accessed using service-oriented techniques, specifically using web service protocols. We're also turning our transaction manager into a set of services. Right? If you think about the way we did transaction management this year, the way we do it this year in the current shipping platform, we have this monolith called the DTC, which is just this humongously large piece of code which has a very obscure COM interface for talking to. What we're doing is decomposing the DTC into a set of autonomous services, which we'll talk about in detail in talks later this week. Additionally, we have common messaging services like queuing, routing, eventing, the stuff that if we didn't build, you'd build it yourself. It would be the first thing you would build. So rather than make you go build a bunch of fairly simplistic plumbing, we build that simplistic plumbing for you. We are not building in V1 of Indigo the Uber queuing system. We are not yet a complete replacement for MSMQ, for example. I'll tell you how we relate to that in a second. We have support for routing of messages, but we're not replacing every Cisco router on your box. We have support for eventing, but we are not a direct replacement for an eventing system such as Tibco. But if you want to implement these ideas on Indigo, we give you the basics as well as the wire protocols for getting them to work. And it's up to you to go off and implement them and use the extensibility hooks to add the enterprise class features you need to the messaging services. So, let's talk about the 4 things you should think about Indigo when you're using it. We talked about the tenets, which just kind of tell you what we were thinking about the programming model. The next thing I want to do is talk about what we're actually getting when we adopt Indigo. The first thing we get is we make service-oriented programming real on the common language runtime. If you're using a managed language, you already had great support for object-oriented programming. We're now making it explicit and easy to write service-oriented programs on our platform. We do this by making boundaries come into focus. What I'd like to do is quickly write a piece of Indigo code using the system.service model. I'm flipping to the demo machine for those people in the back who are doing all the AV magic. So what I'm going to do is write a simple service. I'm not using the PDC bits for this particular talk. I'm using an experimental build, which is indicative of Beta 1. The code you got on the DVDs is not that different, and if you come to the talks tomorrow, I'll explain exactly how different it might be. System.service model. Wahoo. So we have IntelliSense, so you know it must be great. Public class, my service. Right off the bat, this is not a service. I have to take an explicit opt-in action in order to make this piece of code accessible to the outside world. And the way I do it is I annotate my class with service. So my class now bears the service attribute. And when I ask Indigo to take this piece of code and make it visible to the outside world, it will use the norms and conventions of system.service model to calculate what the schema and contract is for my service. I now write a method I now have a class with two methods. What do you think the contract for my service looks like? Any ideas? How many people think it has two methods? Show of hands. How many think it has one method? How many think it has three methods? No methods. You're right. Service orientation is something we do not take lightly. If you really want this thing to be visible to everyone on the stinking planet, we make you take a step. And what's interesting is, the step we ask you to take is largely disjoint from the object-oriented facade to your code. So what I'm able to do is that. The service method attribute is the way I promote an entry point into my code to be part of the service contract. And please note, we ignore CLR accessibility. We do not care about whether this is accessible in an object-oriented fashion. What we're doing here is saying this is accessible in a service-oriented fashion. And it might be the case that if you're talking to me in an object-oriented way, I want you to use a different method. Because I'm going to do things in this method that I really don't want to do if we're loaded in the same app domain. And if we're deployed as a unit and versioned as a unit. I may have to do all kinds of crazy checks here to make sure things work well in a reliable and secure way, which I may not necessarily need to do if we're loaded in the same app domain. So please note, service method is disjoint. It's orthogonal from public-private in my programming language. Excellent. Another thing I can do is, let's say I have a parameter. Oh, one more. Hold on. There we go. So I've got a data structure. Guess what? This code will not compile. What I've done is I've taken my service-oriented entry point and said, please take this data type, which is only defined in terms of object orientation. Because that's all any CLR type knows about today. All we know about is object. The only way I can pass anything other than a primitive, which we obviously need to special case, is for me to mark up my code. Oops, let me use the right keyboard. So what I'm going to do is bring in the new formatter and mark my code up with an attribute called data contract. And what data contract says is, this structural type has a schema. And I'm going to explicitly control how that schema works. And it looks just like the way I do service and service method. But in this case, what I do is I say data contract for the type, and the individual members get marked up with data member. Opt-in. I must take an action for this to be a service. Did you all see that? And if you want more information on the service method stuff, come to the 301 talk tomorrow morning. You want more information on the data contract stuff, you really should go to Doug Purdy's talk, which is later in the week, and the exact time I just don't know. But if you look for a very bright, shiny head that will reflect throughout all of the halls, it will be very easy to find. So, we make boundaries explicit in Indigo. If you get nothing else out of this talk, then my work is done here. Let's see what else we're doing. Indigo and unification. Microsoft loves web services. We love them so much, we ship not one, not two, but 3 stacks to do them in .NET V1. And we gave customers all kinds of choices. And in general, choice is a fantastic thing. Except when it forces you to make other hard choices. Right? Today, a customer looks at the 3 stacks and says, okay, great, there are these 3 stacks. I like that one. And often, I go down the path of stack B and see a feature in stack A that I can't use here. And so I'm forced to do all this weird, multi-programming mode stuff, which I don't want to do. One of the things we're doing with Indigo is unifying ASMX, .NET Remoting, and Enterprise Services, and bringing the best of these 3 models into a single, unified programming model that we're making go as fast as humanly possible. So that if you really want to use this stuff, cross-proc, go for it. If you really want to have the flexible versioning and deployment that you get with ASMX, go for it. If you like the declarative model of enterprise services, where we mark up your code to get reliability, transactions, and security, go for it. A single place to go where I'm not forced to think about what technology do I use. Once Indigo ships and it's deployed, as long as you know Indigo is going to be on the boxes you're running on, which is we make as easy as we possibly can, you just write Indigo programs. It's a lot simpler. We care a lot about interoperation. If you go to Omri Gazit's talk later in the week, he'll talk about the GXA protocol stack, all the work we've been doing with secure, reliable transactions with all of our partners out in the industry. We're deeply committed to making that stuff work, and all of the Indigo infrastructure speaks those protocols natively. This is our primary implementation of WS Security. This is our primary implementation of WS Atomic Transaction and Friends. This is our primary implementation of WS Reliable Messaging. This is where we're making the bet. This is where we're investing in making those protocols accessible and easy to use to all programmers on our platform. And we care about that deeply. Finally, rip and replace sounds like fun if you work at a platform vendor. It's like, wow, it would be so much easier if we didn't have to worry about all that legacy. Let's just screw the customer, right? Screwing the customer seems attractive at first, right? Some people have that instinct naturally. I don't know. Maybe some people at Microsoft do. Maybe we all do. I don't know. Maybe none of us do. But it's fairly easy to screw the customer. It's a lot harder to say, man, they bet on us and made commitments to technologies which we believed in and still believe can continue to work. And so one of the things we're doing in Indigo is to try to leave as few people behind as humanly possible. Once you install Indigo, will your entire machine now become web service enabled and all your COM code and all your MSMQ code and all your other code will just work naturally? No. No. If we did that, we'd really be screwing you. How about this? If I told you we were doing that, we'd be screwing you. We're doing our best. We're investing in making sure that your investments in COM Plus and MSMQ, and by inheritance, Enterprise Services and System.Messaging, goes forward into this Indigo world. We're providing support, which is not in the PDC bits, but will be there by the time we release. We're providing support for using Indigo to interact with existing COM Plus services, for loading Indigo into existing native COM-based applications, like Office, or like VB6. We're also providing support for bringing MSMQ into this web service and service-oriented world and allowing MSMQ applications to live in an Indigo-enabled ecosystem and communicate using all of these web service protocols we've just spent the last 3 years or more getting the industry to jump on board with. So we care a lot about continuity. If you go to Joe Long's talk later in the week, and I don't know the exact date on that one either, but sometime before we leave this week, Joe Long has an excellent talk that shows in detail all the things we're doing to make sure that your investments in COM Plus and MSMQ, and also in .NET Remoting and in ASMX and in enterprise services, don't get left behind. And in many, many cases, the transition is mechanical and simple, sometimes requiring just a simple recompile. So how do I get there from here? If you go to Joe's talk, and I strongly recommend you go to Joe's talk, it's more important than the talks I'm going to give tomorrow or many of these technical talks. Joe's talk really shows you the roadmap of how we're going to get there. Here's the most important slide from Joe's talk. The way you prepare for Indigo today, using the technology we're already shipping and you're already using, is to do the following. Build services using ASMX. It's the closest thing we believe to the right way to build these service-oriented systems. If you need the functionality of .NET Enterprise Services within your service, use it with a clear conscience. No guilt. If you need declarative transactions, Enterprise Services is a reasonable way to get there. If you need object pooling or some of the more advanced features of management that are available in Enterprise Services, use them. Use them within your service. The first thing that should happen in your service should be an ASMX call. But once you're inside that ASMX boundary and you now control the deployment, go in peace. Use objects. In fact, use any object technology you want. The place you might want to use ES is when you need that functionality. Or, if you look at the performance of ASMX today and you say, my God, I could do better, and I would like to use .NET remoting. If you are tempted to use .NET remoting for cross-machine communication because of performance reasons, stop doing it now. If you really care about performance in cross-machine scenarios using our platform, the best way to do it, if you care about performance, is to use Enterprise Services. The throughput and the latency will be better if you use ES than if you use plain .NET remoting by itself. Yes, the binary formatter is faster than ASMX. Yes, the TCP transport is faster than ASMX. But if you really care about performance, you should move to ES now. And guess what else? .NET remoting, all of that speed that we give you over ASMX, which is really fun and feels really good, we do it by removing the doors from your car. If you took the doors off your car, it would go a lot faster. And it turns out the door we take off that most people care about, and if you don't, you should, is security. And while we are adding support for .NET remoting with secure TCP, you're still better off, performance-wise, using Enterprise Services. And I strongly recommend that's what you use it for. .NET remoting's primary goal, primary role in this world, today even, is cross-activating. You got the common language runtime on both sides. You have very clear deployment and versioning situations in mind. And you really want it to go as fast as humanly possible in memory. For that, .NET remoting, live the dream, baby. That's where you want to be. If you're not there, you really should think about using ASMX or Enterprise Services. So, in conclusion, we're not here yet. We're at about 1987. If you think about the 20-plus year arc of object orientation, it was harder in the earlier years than it is today. We have all kinds of challenges as an industry to making this dream a reality and really delivering on a lot of these promises and a lot of this hype. But I firmly believe that, at least at Microsoft, and I actually believe